So this is a viewer. Here's our three-dimensional space where we show the factorized image. The color of each of these dots corresponds to the pixels in this image. This small selection here in white shows up also here in this new space, so you can follow that small part of the space. This is the control box where you set different parameters to the factorization. Right now I have it with these particular arguments. Now if I change sigma s with Fabio's distance metric to be half and run the factorization, you see here's the new result. Now here are the eigenvalues after this factorization. So keep an eye on this if you're interested in that. Okay, so now if I cut the sigma s even farther down and run the factorization, here's what we get. Now if you want to see the dots, you can sort of see what happens as the sigma s drops to a low value, and which is why I think Fabio suggests that you use high values. You can see already that the eigenvalue tail starts becoming heavier. So let's set it back at 100, which is still probably low, but this allows us to study what the effects are of the other parameter. So now if I go from 1 to say 0.5, you can see how this swaps the space. Well, I mean, I'm not sure what it does yet, but it seems like this tool would be handy to study that. Then we can also change the metric. So with the Euclidean metric, you can see that we get more or less, we get back our color space. You have RGB, different corners, and then you have white here. So that's quite nice. And then with the bilateral argument, bilateral distance metric, we get a space that looks like this. And so we can select different points here. And you can see where that point is in space. You can see what happens to lines. If I increase the spatial. So we don't get back the bilateral grid, but it's probably because of these eigenvalues here, which are telling us that the linear embedding requires more dimensions, and in 3D this is one of the optimal distributions, spatial distributions. But it could also be that it's not unique, and that's why we don't get back the bilateral grid. But we need to think about this a little more.